All right, so from going to Fahrenheit to Celsius, we have to do, I always remember this formula that the Fahrenheit is equal to 9/5 C plus 32. And then I just do the inverse of that. What does that mean? That means you subtract 32 and multiply by 5/9 to turn the formula into the conversion from Fahrenheit to Celsius and so on. Okay, so what does that mean? So Celsius is equal to the Fahrenheit minus 32 times 5/9. Right, it's just the inverse of that. We're given Fahrenheit, so we're going to use this one. Okay, and now it's just using calculators. So that's definitely pretty cold, so this is going to be below 0, because 0 is freezing, and we know that 32 degrees Fahrenheit is freezing. I'm getting like negative 23.8 to the nearest tenth of a degree. It does say that, so negative 23.8. This is degrees Celsius. So good job if you got that ahead of me. And then 68 is negative 30 degrees Celsius. Okay, this is definitely very cold because 0 degrees Celsius is the freezing point of water. So that's going to be 9/5 times negative 30 plus 32. Okay, I'm getting negative 22. All right, so I'm going to share a brief video then with you on dimensional analysis. This will help you with your homework.
Learn unit conversion the easy way. The method that we will be using to convert between units is known as dimensional analysis, or the factor label method, or even the unit factor method. But what we call it really doesn't matter. What matters.
Yeah, and let me tell you a little secret. I had to do a science sequence in my undergrad, and so I chose chemistry. I really don't know that much about chemistry, but the way I got through chemistry is using dimensional analysis because I was good at math. We had to calculate the number of moles and Avogadro's number and all of that. And I really just looked at the units. The units are the secrets. They tell you what to do mathematically. So that's this method.
What matters is the fact that this is a versatile and powerful problem-solving technique. So let's just do this. We're going to start with a simple unit conversion problem. A weightlifter can lift 495 pounds. How many kilograms is that? In order to solve a unit conversion problem like this, we first need one more piece of information, the conversion factor. For pounds and kilograms, the conversion factor is 1 kilogram equals 2.2 pounds. Now we're ready to solve this. The first thing you should always do is write down the quantity that you want to convert. This is the number from the question, not the conversion factor. Please also include the units. Next, we're going to multiply this number by a fraction. Inside the fraction, we're going to write the two numbers from the conversion factor. But how do we know which one goes on top and which one goes on the bottom? To answer that question, all we need to do is look at the units, which is why we always include the units in the calculation itself. The quantity we are starting out with has the units of pounds, so we take 2.2 pounds from the conversion factor and write it on the bottom. Next, because we want to end up with kilograms, we take 1 kilogram from the conversion factor and write it on the top of the fraction. Notice that the pounds that we started out with cancel out with the pounds on the bottom, and the units that we have left on the top are kilograms, which is exactly what we want to convert to. The only thing left to do now is plug the numbers in our calculator. You could, of course, put this in your calculator exactly the way it appears here, But maybe you don't have one of those fancy calculators that can do fractions, or maybe like me, you just want to find a shortcut. Because the number on the top of the fraction is 1, this becomes a simple division problem. In your calculator, type 495 divided by 2.2, and your calculator should tell you the answer is 225. Our final answer, therefore, is 225 kilograms. There is one more thing that we should notice about this problem. The fraction 1 kilogram over 2.2 pounds actually equals 1, because 1 kilogram equals 2.2 pounds. In fact, anytime we do unit conversion, we are simply multiplying our initial quantity by a conversion factor fraction that equals 1. Okay, now that we are experts at this technique, let's try a slightly harder problem. A certain car has a mass of 1,920 kilograms. How many tons is that? Just like always, we need the conversion factor before we can solve this, but this time we need two conversion factors. One to convert from kilograms to pounds, and another to convert from pounds to tons. So this is going to be a two-step problem. We start the problem by writing down the quantity from the question, 1,920 kilograms. And then we multiply this by a fraction. The two numbers that go in the fraction come from one of the conversion factors. But what goes on the bottom? Because we are starting with kilograms, we write 1 kilogram on the bottom of the fraction so that we can cancel out the kilograms. Next, the other half of that same conversion factor, 2.2 pounds, has to go on the top. The kilograms cancel out, leaving us with pounds as the units of our answer. When you do the math in your calculator, simply multiply 1,920 by 2.2. This time we are multiplying the numbers because the 1 of the conversion factor is on the bottom of the fraction. Our calculator tells us that the answer is 4,224 pounds. But we're not done yet. We still need to convert the pounds to tons. The second step works exactly the same way. First, we write down the number that we want to convert, that is 4,224 pounds, and then we multiply this by a fraction. We want to have pounds in the denominator of the fraction so that we can cancel out the pounds. But which pounds do we choose? 2.2 pounds or 2,000 pounds? Remember that we want to convert to tons, so we choose the conversion factor between pounds and tons. We write 2,000 pounds on the bottom and 1 ton on the top. Our pounds cancel out, and we are left with tons for the units of our answer. In our calculator, we type 4,224 divided by 2,000, because the 1 is on the numerator of the fraction. Our final answer works out to be 2.11 tons. Okay, we got the correct answer, but it turns out that there is an even better way to solve problems that involve multiple conversion factors. Rather than solving this in two separate steps, we can combine those steps into one step with two conversion factors. Check this out. Once again, start the problem by writing down the quantity that you want to convert. Multiply this by conversion factor fraction, putting what you want to cancel out on the bottom and what you want to convert it to on the top. Notice that so far this is exactly the same as the first step we just did. However, instead of solving this as it is, we're going to multiply it by another conversion factor fraction. We now need to cancel out the pounds that are left on top, so we put 2,000 pounds on the bottom. We chose 2,000 pounds rather than the 2.2 pounds because we ultimately want to convert the quantity to tons. This gives us tons as our remaining units on top while all the other units cancel out. We then proceed to calculate from left to right. If the 1 is on the bottom, we multiply. If the 1 is on the top, we divide. So we multiply 1,920 by 2.2 and then divide that answer by 2,000. Final answer is 2.11 tons, which is exactly what we got the first time. But now we can see how powerful this method is. No matter how many conversions you need to do, putting the conversion factors in fraction form helps you to know when to multiply or divide. Thanks for watching. Please comment, vote, subscribe, or check me out on ketsbook.com.